Hey everyone, welcome back. So today we're going to be talking about merging galaxies. Merging galaxies are an important observation in developing our understanding of not only what's all around us, but what will also happen to us. So I started researching the antennae galaxies, but I found a lot more, which led me to make this video rather than the one I originally intended. So here we go. And merging galaxies are all brilliant, useful, and in different stages. I found many different stages, starting from what we currently live in with the Milky Way, all the way to the nearly fully merged NGC 2623. Now, I know a lot of people are going to be asking, what about the current Milky Way galaxy? Well, as it turns out, the Milky Way galaxy has also merged multiple times. And we'll start with the Milky Way galaxy. So as you can see here, according to Harvard and Smithsonian, large galaxies like the Milky Way were formed by merging and stealing gases and stars from other galaxies. Astronomers discovered that as many as 25% of galaxies are currently merging with others. That's a lot. The Milky Way currently has 50 satellite galaxies, which is not as many as a lot of other larger galaxies have. But what happens is the gravitational interactions between the smaller galaxies and the larger galaxies lead to the mergers. So the larger galaxies pull harder on the smaller galaxies. They get caught in the gravitational attraction and they get sucked in. So we observe them relatively quicker within the Milky Way because of our proximity. Obviously, it takes a little bit longer for us to get data from farther away. So the Milky Way has been studied by many, let me move myself. There we go. The Milky Way has been studied by many astronomers and scientists looking for mergers. They previously found 5, but as you can see here and in the next slide, at the Max Planck Institute, they found evidence of a 6th merger, possibly earlier than the rest of them. In this rendering, you can see what we normally think of with the Milky Way galaxy. But you can see all of these are the stellar streams, which are evidence of these purple satellite galaxies that got pulled in. These are the smaller galaxies that got pulled apart and integrated within the Milky Way. And all of these other little dots are other globular clusters and other satellite galaxies. I know one curious point is asking, well, how do we know where to look or what to look for? So as you can see here, this is Abell. I really hope I'm saying that correctly. Abell 1430. These are two merging galaxies, and these lines show the halo of the diffuse radio emissions that we can detect. Galaxy clusters with signs of recent merger in many cases show extended diffuse radio features. The rest of this explains why there are radio features to begin with, but we can detect them. In order to detect them, we use very specific technology. LOFAR stands for Low Frequency Array, and this is the device that found Abell. And so if you're wondering about this down here, I will break it down. So this stands for flux density, and 80 microjanskis, which is the equivalent to 80 times 10 to the negative 6, or 8 times 10 to the negative 5. That is a very weak signal, but it's also expected for radio features that are farther away. To put this in perspective, 1 Jansky is 10 to the negative 26 watts per meter squared per hertz. And again, these flux densities are common for distant galaxies. So as we end part 1, you can look over this image with me. This is a NASA photo of the Milky Way looking out towards the center. And just from this image, you can pick out a few very clear satellite galaxies. And on that, we will wrap up part 1, and hopefully you will join me for part 2, which will discuss even more merging galaxies and possibly what will happen to, or well, at least what scientists believe will happen to, the Milky Way and Andromeda when they merge. Please remember to like, share, and subscribe.